Now in this episode we will start solving problem on the subject arithmetic progression. As we already covered all the theories, which are basically the basic theories. Why I am saying basic theories? There may happen some of the specific series which are very common and can be used commonly for solving other problems related to arithmetic progression, such as if I see the example of a series. Let's say the series of a natural numbers, the series of natural numbers where it starts from 1 and consecutive terms are increased by 1. So in that series, if I say the series is considered to be to the nth term, so whatever the sum or the particular term if I establish, that can be used for any other case where the sum is the arithmetic progression is not a straightforward, but maybe a combination of several you can say the standard series, just like I just taken an example of natural series. Those kind of thing can be utilized directly without further calculating for the same. That means if somewhere in AP series there is a combination of natural series, odd series, even series, there those kind of series, the sum of the sum in case it is coming, can be utilized the direct formula for that. So those particular series, the sums I will explain. I will establish some formula, and I would like to tell the viewers to remember those results to be used for any case it is to be used directly. Okay, so now the first problem on arithmetic progression comes like that. So the progression below is an AP. So there is a series, then some numbers are given which we can take as a consecutive numbers for an AP series starting from the first term. Now first thing you have to prove it is an AP series. Okay, your first task is to prove it is an AP series. So if I go with the definition of the AP series, the difference between the consecutive terms, as it is given 3 terms, so if I can prove the first 2 terms difference is same as the second 2 terms difference, then it can be said to be an AP series. The first task will be over if I prove it so. Second thing, find the next term of the AP series. That means if it is an AP series being proved, then what is the next term to the right to the third term? So that is my task. So we will go by one. The first, by seeing it, somebody may not tell that it is an AP series, because in AP series generally if I deduct it, now root over 50 minus root over 18, you doesn't have any clue how to deduct, because under root, because it is a kind of surd, and that too it is not a perfect surd, it is a mixed surd. So deducting this together may be difficult unless we can come to some form of this surd by simplifying it. So my task is to find the simplified form, that means the mixed surd form. So if I see it, if I write it like that, 3 consecutive terms, Okay, now what we'll do, we'll make it simplifies. So for simplification, what you have to do, you have to write all the factors, prime factors by which it can be established, which can be I mean to say, by which this number can come. So 18 can be 2 into 9, and 9 can be written as 3 square. So all these are prime numbers we can establish. The second one is, if I do it similarly, 2 into this will be 5 square. Similarly, if I take it, it must be 2 into 7 square. Okay, so now further, by simplifying, 3 square means if I remove particularly for 3 square the root, that 3 will come out, and as because 2 is not a square in square form, this is not a perfect square, so it will remain inside the root. Similarly, for this it will be 5 root 2, and for this it will be 7 root 2. Okay, now if you have come across my classes on surd, then you must know, while we are deducting two surds from each other, so what is possible for us, instead of making it in a decimal form, what we can do, if I want to deduct it 5 root 2, 3 root 2 from 5 root 2, so the root 2 can be taken as the common factor to this term. So that can be taken out outside, and the remaining the integers can be written separately, and that can be deducted. This could be one of the rule of surds. You can separate the surds if it is common factor to the terms, and by deducting the integers from it, ultimately this root 2 can be taken as adjacent to the result of the subtraction of this integers. So ultimately this can be written as 2 root 2. Now the same thing if I do with the next two terms, so that means 7 root 2 minus 5 root 2. So similarly, you can see it, if I take root 2 outside, it will remain as 7 minus 5, and that is 2. So ultimately this also comes as 2 root 2. So we can see the difference for both the cases are same. That means if I deduct the first term from the second term, whatever difference it is coming, and the same difference we are getting from by deducting the second term from the third term. So as per the definition of the AP, when the difference between the consecutive terms are equal, that series can be said as AP. So the first thing has been proved. So our answer would be, as we can see, the consecutive term, the difference of the consecutive terms are same, so series has proven to be an AP. So the first thing is over. So my first proof is over. Now while doing the first one can definitely or easily can say the things are going like that, that root 2 is common to the terms, and we have proved that it is AP. So obviously by seeing the series, one can say that the next term should contain root 2 as its adjacent surd, and the integers that are moving on by increasing 2 each time. So 3 from 3 to it is 5, 5 to 7, then obviously the next term will be 7 to 9. There is no ambiguity in that by saying that. So by that easily, without even formulating, to find the next term, so the next term definitely it will be first, second, third and fourth time. By the formula of fourth term, we can also establish the thing, or otherwise, if you don't want to waste the time, by seeing the similarity, you can directly write down the next term, that is this one. Or else, if it is 3 root to the first term plus n means 4 minus 1 into the common difference is 2 root 2, you can write 2 root 2 here. So what is the result ultimately? 4 minus 1 is 3, 3 into 2 is 6, so 6 root 2, Now for addition also it follow the same rule. Root 2 can be taken common. 3 plus 6 is 9, and ultimately root 2 will be kept as adjacent to this. So this is a mixed, and if you want to bring in the form of the series how it is being written here, the term will be 2 into 9 square, because 9 it is outside. Now if I put in, it will be 9 square. So 9 square means 81 into 2, so that means 162. So my answer for the next term will be 162. That will be a correct way of writing the terms. You should not keep it in the form, because the results needs in the same form as the series has given. Okay, so you always to be very perfect while you are computing the results. Okay, so this is your first problem. Coming to the next problem. Find A and B. Okay. Find A and B such that numbers A, 9, B, 25 form an AP. So this is already declared that these terms are in sequence follows the series and of an AP. So that means these terms are consecutive to each other. Consecutive terms. There is no terms in between that is not being said. It is following the AP series, and these are the consecutive terms. So definitely we can apply the formulas for AP. So to find A and B, the first thing is that we know the difference between the consecutive terms has to be same. So the first for the equation that can be established by saying 9 minus A, that difference must be equal to B minus 9 as per the definition of AP series. So from there we can write A plus B. If I bring A one side and the digit one side, because we want to establish a relation between A and B. So this is 9 plus 9, 18. So this will be your first equation. The same if I follow for the next three terms. So definitely you can say the B minus 9, because the common difference is same always for all the terms. So B minus 9 will be equal to 25 minus B. Okay. So now here the unknown is B, so you can keep B one side, so that will be 2B, and if you can move the digits on one side, that will give you 34. Okay, so now from here B can be calculated as 17. So once you have found that B, putting the V value here, you can find the A is equal to 18 minus 17, so that is equal to 1. Okay, so this is your task to find A and B. So definitely the rule of AP, by establishing two equation, okay, you can find the unknowns, and the result of A and B will be, you can write A and B is 1 and 17. This is your answer. Fine. Moving to the third problem. It says find the 21st term of the AP. So now again it has given some numbers. Now prior to moving to find the 21st term, just for the clarification of the doubt, see if it is an AP series or not. So for that, what we have to do, we have to see the difference between the consecutive terms. So first we will do between these two terms. Now let's see what is the answer for that. 5 by 2 minus minus. So how it is coming? Minus of 5 by 2 minus, as per the rule you have to take the difference, that means minus, and this 5 also carrying a minus, so you have to bring it inside a bracket so that confusion must not happen. So after that, after one step, you have to remove the signatures. By removing the bracket, what you have to get a change, minus into minus, that will give you plus, so that is 5. So ultimately it is coming 5 minus 5 by 2, Okay, so 5 minus 5 by 2 is definitely, you know, it is 5 by 2. So now first part is over. Second part you have to check 0 minus of minus 5 by 2. So 0 doesn't have any meaning. So minus and minus, that will give you plus 5 by 2. Now here you can see the results are matching. So that means it is an AP series that been established and cross-checked. Now we have to find the 21st term. So we can write T21 as per our rule. Now in this, what we need the first term. That first term is minus 5. So you have to remember to keep the terms along with the sign given. So to separate it, you have to bring one first bracket, so that there should not be any confusion among for the signs. So okay, so first term plus n minus 1, that means 21 minus 1, and d is, in this case you have already calculated. This also help you proving that it is an AP series, and by that way you can find the common difference. So the common difference also has to be calculated, and you have already found out during the course. So this is common difference CD to 5 by 2. So you can put it, then 5 by 2 carrying positive sign, that is okay. And now ultimately what is your result here? Minus 5 plus 21 minus 1, that is equal to 20 into 5 by 2. Now if we cancel it or simplify it, you will get something 5 plus 10 into 5, that means 50, and finally you will get an answer of 45. Okay, so 21st term of this series, if we proceed, you will get 45, the answer for the 25 series, 21st term. Okay. So I'll end up here. In the next video, I'll move on to the next problem, that is problem number 17 and onwards. But maybe prior to that, I will show you some of the cases which are very standard series that I have just discussed before starting solving the problems. So those standard series I have to establish, because any time that may needed to put the value of those standard series. That's like I said, the natural series, the odd series, okay, or the even series, like that. So those can be used as a direct formula for any case, any other sum where it has to be used directly. Okay, so thank you for now.